Hello again, everybody. I hope you guys are doing okay. I know some of you, when you were in class, would always look at those quiz calendars that I had on the front desk. Those are at home right now, and I happened to get a laugh out of one of them that we had this last week, which was the factor crap calendar. And so we'll have you look at that for a minute. Research has found that dog fleas jump higher than cat fleas. See what you think that might be. And it turns out that indeed that is a fact, but as they say, but cats can jump higher than dogs. The good news, at least from your point of view, is that there's just 3 weeks to go in our online class, and that actually counts this week. So we're going to learn a little bit of new stuff this week and next week, and then we'll tie everything together and be done with Chapter 0 and ready for summer. You guys should remember that last week we were talking about quadratics. We reviewed factoring, and we also talked a little bit about the quadratic formula. This week we're going to expand a bit on that, especially dealing with factoring, and use that to solve some problems you probably wouldn't even have looked at before. Most of the problems we're going to look at this week look something kind of like this. It says find the point of intersection of y equals 2x squared plus 7x minus 1 and y equals x squared plus 3x plus 20. So think about that for just a second, and then we'll figure out how to do it. So the key idea here is you're looking at a couple of parabolas. And those parabolas are going to cross over each other somewhere. In this case, they cross at a couple of different places. And that's going to end up being the points of intersection. So I'm trying to figure out where do those parabolas cross. The important thing, both with this problem and pretty much everything we're doing this week, is that things intersect when their y values are equal. And so if I want to know where these parabolas intersect, what I do is I take the functions that I was given earlier and I set them equal to each other. I have 2x squared plus 7x minus 1 equals x squared plus 3x plus 20. And now what I've got to do is solve that equation. And it turns out it's actually not all that hard to solve that equation. The most important thing is I have to get everything on one side so that it says equals 0. What I did here is I subtracted x squared on both sides, I subtracted 3x on both sides, and I subtracted 20 on both sides. That left me with just 0 on the right-hand side, and on the left I got x squared plus 4x minus 21. Again, I'm just taking everything on the right, moving it over to the left, and now I've got a problem an awful lot like what you did last week. And what we're going to do to solve that is to factor. If I find stuff that I can multiply to get negative 21 that adds up to 4, that's why my factors are x plus 7 times x minus 3. And that means that the answers are going to be negative 7 and 3. But we're not quite done, because we're trying to find the points of intersection. And that means I'm looking for both x's and y's. So far I figured out that x could be negative 7 or 3, but I've got to figure out the y's that go with them at those points. And all I'm going to do to figure out those y's is just go back to whichever of those original functions looks easier, doesn't really matter, and plug those two numbers into that function to figure out what y's got to be. On those calculator screenshots, I actually plugged into both of the functions, and I did that just to show you that you get the same answer either way. You don't have to plug into both of them, you just need to pick whichever one looks easier. In this case, I probably would have picked the second one if I was doing it myself, and taken like negative 7 squared plus 3 times negative 7 plus 20. That gives me 48. Then I do 3 squared plus 3 times 3 plus 20. That gives me 38. So my points of intersection are going to end up being -748, and 338. The basic process anytime you want to find points of intersection is you take the functions you're given and set them equal to each other. Again, that's because they intersect when they're equal. You do whatever it takes to solve for x, and usually that means factoring or possibly using the quadratic formula. And finally, you plug in and figure out what y is. We're going to take a look at a few more examples to hopefully make sure that you got the idea correct. Next one here, it says find the points of intersection of 5x squared plus 7x minus 11 and y equals 4x squared plus 20x minus 47. You might want to take a couple minutes and just pause the video and see if you can work that one out. And again, the key to the whole problem is set them equal to each other. So 5x squared plus 7x minus 11 equals 4x squared plus 20x minus 47. Once you've done that, you got to get everything on one side. So move everything over to the left, and I get x squared minus 13x plus 36. You do need to be careful that you're always doing the opposite of what it says. So I, for instance, subtracted 20x and then I added 47 to come up with those answers. So once you got everything over on the left-hand side, what you've got to do is factor. Again, we're looking for stuff we can multiply to get 36. It's going to add up to negative 13, and that would give me x minus 9 times x minus 4. The opposites are always the answers, and in this case, x is either 9 or 4. There's always one more step, which is figure out what the y is. Again, I can go to either formula. On the right-hand side, I actually plugged everything here into the first of the formulas, and you can see I came up with 457 and 97. And again, just to show you it works both times, the little one that's kind of at the bottom middle, I plugged into the other formula, and yeah, I get those same answers. So my points of intersection are going to be the point 9, 457, and the point 4, 97. And here's basically that same thing. We're supposed to find the intersection of 3x plus 1 and x minus 4x squared. Again, if you want to pause the video and work that out, that would be a good thing. So first we set those two functions equal to each other, and then I've got to get everything on one side. I moved everything over to the left-hand side, and I also made a point of putting it in standard form with the x squared first. You're going to end up with x squared plus 2x plus 1 equals 0. This time when you factor it, what you get is x plus 1 times x plus 1, or you could just write that as x plus 1 squared. And that means we just have one point of intersection rather than two this time. It's what we call a double root. But you'd end up with just negative 1 as the only x value that works here. You substitute into, again, either of the equations, you're going to get the point negative 1, negative 2 for the final answer. And I purposely chose this example because there's a problem in the assignment that's kind of like it. I'm not a great fan of fractions myself, and I know a lot of times when people see those, they just kind of shy away from them. But it's really not a whole lot different than other problems. It says we're supposed to find the intersection of y equals 3 halves x squared minus x plus 2 and y equals x squared plus 2. And we're going to do that pretty much like all the rest of the problems. I'm going to start by setting the two functions equal to each other. So 3 halves x squared minus x plus 2 equals x squared plus 2. Now, something you might notice is both of these end in plus 2. And that means I can make my life a lot simpler by just getting rid of those 2's, subtracting 2 from both sides. Now, there's actually a whole bunch of ways that you could proceed next. When I see fractions, though, I'm not a huge fan of fractions. And that's why typically what I try and do is get rid of them as soon as possible. And what I did between the first line and the second line here is I multiplied every single thing in this problem by 2. Because what that does is it cancels out the 2 that's on the bottom of the fraction. So 3 halves times 2 gives me 3x squared. In the middle, I multiply by 2 and get minus 2x. And at the end, we're going to get 2x squared. Again, I just multiply by whatever the fraction is I'm trying to cancel out. Next step is exactly what we've done before. I'm going to get everything on one side, and then we're going to factor. Again, I kind of chose this problem on purpose because sometimes people get goofed up when there's no constant at the end. They're not sure what they're supposed to do to factor. What you can always do on a problem that just has x squared and some x's is take out a common factor of x. You're basically like doing the distributive property backwards. I know x goes into both parts, and if I divide both of them by x, I'm left with x minus 2. So x times x minus 2, that's what this is going to factor into. And what that means is that my possible answers would end up being 0 or 2. And like on all the others, I've got to figure out y as well. This time it looks to me like the second equation is by far the easiest, so I'm going to plug in 0 and 2 into that equation. I end up getting the point 0, 2 and the point 2, 6. There's one more example we're going to take a look at today, and this one is a little bit different, but it actually is along the same lines as the one we just got done doing. Here it just says solve for x. It's not saying we need to find a point of intersection, it's just solve. And we've got the equation 1 equals 40 over x squared minus 3 over x. Now, the difference this time is it's just an equation. But once again, it's got some fractions, and fractions can be kind of annoying. So what I'm going to do is multiply to get those fractions to cancel out. And what you can do is multiply by a common denominator. You want to find something that's going to cancel both x squared and x. And x squared will actually cancel both of those. If you had wanted to multiply by x cubed, that would also work. It just makes it a little bit harder later on. But I multiply everything by x squared, and that's going to end up getting me on the right track. So when I take 1 times x squared, that's just x squared. In the middle, the whole point is I want the x squared to cancel, so what's left is 40. And at the end, what happens is that x on the bottom will cancel one of the x's in the x squared. That's why I have minus 3x at the end. So x squared equals 40 minus 3x. And the basic process in the end is the same as on all the other problems. We're going to get everything on one side and then factor. When I do get everything on one side, we've got x squared plus 3x minus 40 equals 0. That's going to factor into x plus 8 times x minus 5. And so that means our answers are negative 8 and 5. Now, those are our answers. That's all I have to do. There's nowhere to plug back in and try and find an answer this time. What I've got going on over at the bottom right is I just wanted to show you that, yeah, this really does actually work out. Our original problem said 1 equals 40 over x squared minus 3 over x. And what I did is I plugged these things into the right-hand side of that equation and showed you they both work out to be 1. So yeah, both of those really are solutions to the problem. You don't have to do that. I just did it to show you that, yeah, it really does work. The answers are just negative 8 and 5. And that does it for our notes for April. And again, we do just have 2 more weeks coming up after this week, so we really are getting on toward the end of things. Your quiz this week will be another of them where you're going to work out stuff on paper, take a picture of it, and then send it off to me by either email or text. And hopefully that'll go pretty decently. If you do get stuck along the way, always feel free to contact me to try and get you on the right track with things. We'll leave it at that for this week. I hope you're doing well and that you do have a good week.